Boom. Hello and welcome to Practicalli. My name is John Stevenson. Thank you very much for joining me. And today we're going to do some more data science. Well, not really data science, but certainly the visualization of things. I'm not a data science expert, or a visualization expert yet, but I'm certainly something I'm looking at and quite interested in. And there's some really nice libraries in Clojure to help you do a lot of things in the data science realm. So we're going to explore some more about the Oz library that we looked at last week. So I started building this data science dashboard and exploring how to get there as well. So I saw this dashboard that the UK government had created. So this is from Public Health England. It's from gov.uk, and it's kind of gave me some inspiration about what kind of things I could start to visualize. Certainly about the COVID pandemic that's happening at the moment as well. It's very relevant. And so we looked at the project to do that. So we're going to look into that a little bit more as well. If you want to get in touch with me, then all my videos are on the Practicalli website, and the books as well. And if you want to get in touch with me, then via Clojure in Slack, the Practicalli channel. And if you don't have an account, you can sign up there for free as well. And you can also support me and keep me motivated by any of these methods as well. So what did we do? So last week we did data science. We did a COVID. So I did this COVID-19 dashboard, which is using Oz, and I didn't include an image. There we go. It's basically just created a simple dashboard with in the design journal, and so basically creating some mock data, doing some plots, some different ways to visualize that data, and then doing basically just creating a dashboard with some hiccup style language as well. So using tags, but keywords for tags and so on. So we're going to delve into this in more detail, and I've created a new project just to keep you on your toes called Oz Visualisations, just to explore kind of the different kinds of graphs and visualizations that we can create as well. So if you go to Practicalli Oz Visualisations, then these are the screenshots I've just taken from the code I finished off this morning. So I did get up a little bit early to finish this all off. So these are the kind of things that I've created, and all these have got code in this project. This is a deps.edn project. There's nothing too complex about it. It's just it's just generated by CLJ new, and the only thing I've added really is the Metasaurus library. So we haven't really added, I'm not using any other dependencies there. I'm just generating my own data sets. So I'm not scraping any data at the moment. So it's very simple, intentionally kept simple, just so we can see how to do things with Oz as well. Oh, we get an echo. Somebody's saying we're getting an echo. Is the voice echoing? I have no way to tell. It shouldn't be. I'm not displaying that anywhere else. I'm not sure where the echo is coming from. Is anybody else getting an echo on the chat? Okay, I'll continue, and if this doesn't work, I'll just redo it all again. Okay, where did we get to? Okay, so we created a project. Crapola, sorry. There we go. Oops, no sound. I'm having I'll start again. Where do we get to? Sorry about the sound issues. I'll go back to where we started from. Oops. Boop. There we go. I am awake, honest. I am awake now. Okay, so we've got our Oz Visualization project, which I've created, and it should be working now. Sound is working now, hopefully. So we've got this project called Oz Visualization. It's a deps.edn file, deps.edn project, and I've just added Metasaurus Oz here, and it is that's all I've added to the project. Just a simple dependency. We're not using any other libraries or anything, and all the data I'm generating, I'm just writing a few functions to do that. And let's see. Yeah. So, and then inside the if we go back to the source file, and in source file there's the some mock data that I've been creating, but I've also created some mock data in the org visualization. So this is the main namespace to look in, and we've got Oz core required here, and some mock data as well. And I've created there we go, plus, and we've created the all the visualizations and some of the mock data in here as well. Eventually I'll tidy this up and put all the mock data back into the mock data namespace and keep it all in there, keep it all nice and tidy that way as well. Oh, cool, excellent. There is a bit of delay in the broadcast, so I never quite know if everything's working. So thanks for your feedback on that. Okay, so let's look at that in my editor. Let's make this a little bit bigger. Oh, that's smaller. There we go. Whee, that's bigger. Too big. There we go. Okay, so this is just the Oz visualization file in under source Practicalli, and I've got a REPL running already. And now I can evaluate the Oz start server, and then my browser is just telling me a notification it's popped up a new tab, and now it's got this page that's listening for views that I'm going to create, and it's just a simple process that's running listening on a WebSocket, and then I can push a view to that and it'll display the views. Before we create any views, then need to generate some data. So first thing was, well, how do I actually create some data? I wanted to, so this section is about visualizing weather. So I wanted to visualize the weather in April, which seems to be quite random. It seems to be getting quite hot quite quickly. There's a bit of a jump, so it is quite random at the moment. So I thought, well, if I have a weather data structure that looks something like this, so typically with Vega and Oz data. So Oz is basically a generator for something called Vega-lite, and the kind of data structure that seems to be quite typical is a collection, in this case a vector, and inside the vector there's just the actual data, and each data entry is kind of its own structure, and then that's just repeated. So this is like a map. And so we get a vector of maps, and then in each map we have the explicit data. So we've got date, temperature, precipitation, and the type of weather we're doing. So that's kind of the information I was looking to generate, and just to put some randomness in there to save me typing, then I just created these two little random generators, which actually spent far too long trying to figure out how to do this one. So this is basically doing generating a random int, and between the maximum and minimum values we're giving. So it's April, so we're not going to get into the 20s, although that might happen actually. And so I put in a minimum maximum range, because rand int itself will take a maximum, but it doesn't take a minimum. It's not like the range function. So I've kind of built the same kind of thing you would get around a range function. So what we're doing is generating a random int and taking the maximum number and then minusing the minimum number. So in this case we get 19 take away 8, and so we get a random number between 0 and 11. And then we add the minimum number back to that, and that gives us a random number between 8 and 19. So that's very straightforward. And then the maths one, so to get a so temperatures are usually expressed just as an integer value in most of the data sets I've seen, but precipitation is defined as a single, like a decimal value, but with a single decimal point value. So we get values like 10.5 or something like that for precipitation, whereas for weather we'd get something like 16. That seemed to be, looking at the data sets, I don't know if that's universal or just the ones I've looked at, but those are the kind of things I was trying to model, just to kind of get closer to the real world. But then how do I get a decimal point without all the extra numbers at the end? So this is the way I asked the audience and got some help on that. So basically we generate a rand, which will generate a random decimal number. And what we do is we convert that into an integer just by rounding down. Well, first of all, we times it by 10. So we get a random number. So we get a random number, and it's got a lot of decimal points there. If we times it by 10, then we're actually getting, if we convert this into an integer, then we're going to get 73, and then we can just divide that by 10 again. So we still get the same random number in the same range, but we actually get that number with a single decimal point. So if we do math round on there, so now we're getting 154 because we've timed 15.4 by 10, and so now we can just evaluate that, and we get a 1.2. We get a decimal value just with a single point. So that was my sneaky way of getting around creating that. Could have done that with format, but then I get a string, and then I'd have to convert that back to a string as well. So that's the way I created the data. And then I just use that data. So I just created a def for this, and we've used that data into something called defined this thing called a strip plot, which is our view. And we just put that into the data section, into the values. And inside the values, this is where you put your collection of maps that contain all your data. And that that's basically converted into kind of a form of JSON that Vega-lite uses. But we don't actually change the data. We're not decorating the data itself. We're not changing the data structure of the data. That always stays the same. But what we're doing is we're going to define how we want to visualize that data. It uses something called a mark, which we'll see is basically the type of visualization. Do we want a bar chart? Do we want a line plot? Do we want a pie chart? So there's lots of different marks you can use. And if we go to the Vega-lite web page, which I did copy over there we go. And so this is specification for Vega-lite. This is what Oz is generating for us, and it's essentially a JSON data structure. But we're using Clojure to generate that because it's nicer to work with in Clojure. And you've got all these mark sections, which is basically the visual building block, as it says. And there's lots of different types you can have. Where is it? Oops. Yeah, so you can have pie charts, which is an arc. Although I couldn't actually get that to work, but we'll see that later on. You can even have donuts as well. And you put labels on things as well. So this is the kind of like the category of kind of the visualization you want to create. And then there's things like, bar charts and histograms and so on. So these have all got kind of, some example data, how you create them, and then what they look like when you run them through them. So this data structure is in JSON, in the Vega-lite format of JSON. And what you can actually do is just convert this into Clojure. It's fairly simple to convert this. Even just typing out, it's very simple. So this is just a a data keyword, a mark keyword, and an encoding keyword. And yeah, so the first element is always like a keyword in the map. So it's fairly easy to translate from JSON into Oz, which is what I've been doing. So here we've got the strip plot. So we've got the three sections. We've got data, which is our data, which we're not changing, but then we're adding, I guess, metadata to that to express how we want to display that data. So in this case, we're just going to have a tick plot, and how we're going to create that, how we're going to match the data that's in our values with the actual mark, the actual type of visualization. We can express what the x-axis is and which field it's using. So here we're using the field temperature from our values. So here we've got like the temperature key, and so it's basically using a pattern matching the temperature key in our data structure. And it's quantitative, so it's just going to use the values as they are. And so yeah, so if we evaluate that, and then we can just use that in the view. You can kind of include. You could just put all the data in the view as well, but I think it's slightly nicer to kind of do this def, because then you can also use it as a dashboard, as we'll see later on. Okay, let's see if that worked. Oops, press the wrong button. What did I do there? Oops, what did I do? Oh yeah. So we go back to the web page. Where's my Oz? There it is. Just itty bitty, teeny weeny. There it is. But this is it's a very, very simple plot. So these are the kind of different data points across this. So obviously it's generating random temperature, and these are just indicators about where which temperatures are. So the thicker the bar, the more temperatures are in that range over the entire data set. So that's a fairly simple visualization, but we could do more. So that gives you an idea that we're just taking some data, we're adding some metadata on top of it, and we've created our visualization, and then we can just view it. So it is quite simple from that point of view, and then it's just a matter of understanding what kind of visualizations and how you get the encoding to work with those visualizations from that data. And then sometimes you realize the data isn't quite right as well, so you might need to change that. So now we've got a custom one. So all I've done here is just added I've added a scale and axis. And so the axis is kind of affecting in this case, the x-axis. And so all we're doing here is just putting a title on this. So rather than having the default title it was using of temperature in the last one, let's look at that. Yeah, so we've got temperature here. Instead of having temperature, if we do this, then we're going to get a custom title. So this is more explains better what the data is all about as well. So we don't have to change the data structure itself to get the right kind of names for the labels. We can just put our own labels on there as well. But Vega does give you some nice kind of sensible defaults, so you don't have to always can add this information, only if you want to elaborate on the defaults that Vega provides. And then also added a scale on this as well. So if I did evaluate that, didn't I? Grumbles. I didn't have breakfast. And so this is kind of different because it's setting a scale, a range between where the values are going to be. Well, the overall length of the plot. So if we looked at strip plot, you can see it's going from 0 to 20, and then when we evaluate this, it's it's going from 6 to 22. So the values are slightly different. So you can express the range. So again, having the having this kind of side by side would be quite useful. Let's do that. Oh, wrong one. Oops. 3. There we go. That might be easier. Yeah, there we go. That's better. Boom, boom. So then you can kind of experiment. Oops. If you can type with the ranges, and I could just change the ranges here to kind of get kind of the right view of the data as well. So again, sometimes visualization, you need to understand what the data is actually doing, what the kind of the range that's the most valuable view of that. But because we can just simply just push a new view straight away, and you can actually have a watcher as well. So when you change and save a file, it'll actually do just like Figwheel and other kind of loaders. It will actually load it in the new views as you change them, as you change and save the file. So we could do that as well. So again, it's very easy. This gives you a lot of feedback about how to create your visualizations very, very easily. Yeah, there we go. And so, but it doesn't really give us much information there. So let's put this into a different view. We want to be able to see the kind of the range of temperatures, not just the values, not just the range of temperatures, but the values for each day. So here we've taken pretty much the same. We've got the same data, but we're going to use a bar instead of a tick. So it's going to be a bar chart, and we've got not just an x-axis, but an x and y-axis. And we've got the same kind of fields here as well. We haven't changed anything there. But we've added this y, which is an aggregate of count. So it's going to count how many days have the same temperature. We evaluate that. Bring my thing back. And now we get the bar chart back again. So we've still got the label on the axis, the x-axis, but now we've added a y-axis, so we can actually display that we've got 3 days that are between 14 and 15. So this gives us more, different view on the same information very, very easily. So you can have those, and we haven't had to change the data. We've just put it a little bit extra details around the encoding. But we might want to make it a bit more expressive and add some color to this. So now we've got color. So I've added, as well as an X and Y encoding, I've added color encoding as well. This is going to encode on the weather, which was is one of the keys in the original values. So there's in the weather data, there's a weather key, and if we look at that. Boom. Oop. Yeah. So weather, sun. Oh, make it a little bit bigger. Yeah. So you can see there's lots of different weather patterns: rain, drizzle, rain, snow, fog, drizzle. But we do get sun in the UK occasionally. That's nice. And so we can go in. So that's all I've done to change that. I've just added this color section to the encoding part. So I haven't changed the what we're visualizing. So evaluate that, and then update the view, and we get colors. Because we're using colors, because simply just by adding this color section, then Oz is going to generate a stacked bar chart. So we can kind of see the in temperatures between 12 and 13, then some of that was raining and some of that was drizzle. So that's nice. April showers. They're called April showers for a reason. And we've got some sun like we've got today, but we've got some rain as well. That sounds a bit like April. And we don't have any snow. Oh, we do have some snow at 16 degrees. That's some very dodgy data there. Again, my first attempt at generating that data was not perfect, but we're going to fix that a little bit later. Oh, actually, we're going to fix it next. But again, we say we haven't changed any of our original data source. So once we get it into that collection of maps, then it's very easy to express it in different ways. And now we're going to try and improve that data a little bit. So let's have a look. So I did have a little play around about how to create a nicer map. So actually to tie up the type of weather with the actual temperature. And again, it's I've called this like better data, but not great data. Again, when we pull information from like a real data source, it would be much more accurate. But if I've assumed that if a temperature is less than 2, then it's going to snow. If it's between 1 and 3, then it's going to be foggy, then rain and drizzle and sun. And I think that covers all bases. I did get my I did miss out a few values in between there, so I did put in an otherwise changeable as a catch-all, just in case I miss a number out here that it generates. I think this is probably a bit optimistic. If the temperature is above 9, then it's going to be sunny. There we go. But it gives a better value. Or it gives a more realistic kind of weather patterns to based on the temperature that we get. And so then all I'm doing is just creating a range of days. So assuming there's 30 days in a month, I'm just going to map this data generator. This is going to generate basically this map for each day that we give it. So we're passing in a day. It's going to set the day to day with a day key to day. Temperature is just this rand int that we've got. So it's just the random integer. And then the weather is going to be based on the value of this random integer that we created. Just going through this cond. Okay, and there we go. Yeah, so when we generate this, we get a new data set. Ooh, there we go. And hopefully a little bit more realistic. But again, it's still just mock data just to help us understand, the different kind of things we're visualizing in our structures. So I've just put that into the values. So again, I could put that as I could put that whole expression as a defen, or here it's just a simple expression. So I've just kept that as is. And so this is going to generate random data each time. And then we're still using bar. We haven't changed any of the rest of it. So we evaluate that. Bring back my map here, and hopefully we get a better spread. Oh no, what's it done? There we go. So it's got a nicer spread, but it's gone and pushed it over the boundaries of what it's drawing, so it doesn't look that great. So let's see if we can fix that. Oops, wrong one. Where was that? Oh, scroll down. There we go. There we go. So it's because we've got this scale on here as well. We were using that scale for the plot to kind of set certain limits between it, and because we're changing the values now, we're going between 0 and where are we going? Oh yeah, so the temperature. Oh yeah, we're going between 0 and 30 as well. So that's going to generate a between 1 and 30. Sorry, when we're actually generating. Oh, that's the numbers, isn't it? No, yeah. So the temperature is going to be between 0 and 30, which might be a bit optimistic for April. But then that's why the graph is going over it, because it's generating numbers beyond like the 6 and 22 that we actually had as the kind of the domain of the values that we were looking for. So we got this still got this scale set, which is why it's kind of going over the end, because we've got looking at between 6 and 22, and we've got values lower than 6 and greater than 22, so they're kind of spread across the boundaries of the actual image. So we can just remove that basically. So just basically remove that scale. I've kept the temperature label, and if we do that and evaluate, there we go. So that's much better. That's quite optimistic that we've got a lot of sun. Obviously, when it's colder, we're getting a mixture of values, and we're grouping the values by like 5 degrees each time, and that's just a default that Oz is taken based on the range of numbers. And again, you can override those defaults by just again setting more values in the encoding section. But often Vega and Oz gives you nice defaults as well, so it kind of saves having to write any extra stuff there as well. Cool. So we can make some nice visualizations, and the stacking does help kind of express kind of the changeability of weather. Usually when it's warmer, then it's much more like stable weather. When it gets colder, then it kind of fluctuates a lot. So in the winter and spring, you get more kind of variations in weather. And then in summer, it's always sunny. No, it's not really, but based on my OK data, that's what it's kind of suggesting. No questions so far. Cool. So all of this is really just it's just a map. It's just a Clojure map we're creating with keywords and values. And once you've done a little bit of Clojure, then that should be fairly second nature. It's how we express all our data structures mainly. So we use maps quite a lot, and vectors if it's just a collection of data as well. I think that by far those are the two most common ways to model information in Clojure. And then we do have sets as well if we want some unique data as well. So we've got color, but those colors didn't really represent the kind of like we've got green for sun. I mean that's yeah. I mean, if it's sunny, then you're probably out in the countryside, hopefully in some nice green fields or some nice green parks you can go and sit in. But you might want your own color scheme in that, so we can add that too. So here we've added our own kind of scale, and so we scale based on the actual type of weather, and then for each of the values in our domain, we've created a specific color that we want to use for each of those domains, and that way we get the color charts that we actually want. So if we evaluate this, go back, so instead of green, then we've got yellow for sun, and so we've got gray for fog, and so it's easier for us to understand what this visualization is trying to say very quickly, because we can relate to yellow being warm temperature and it being sunny. We can relate to dark blue being wet, and light blue being not so wet, and grey being like foggy, and so on. So it just helps a little in the understanding of somebody when they look at this visualization, just to be able to use your own specific colors to represent certain feelings and information. What did I do on here? I forgot what I've done on here now. Oh yes, and so yeah, we've got a stacked bar chart as well, so we can see all the information all in one view. But we can also do multiple views of the same information. So here, instead of doing, so what we got here, so we defined the color to put color on just using field and type, and then scale to specify the specific colors that we actually want to use. But instead of using color, which creates a stacked bar chart, we can actually use column, and that will create a separate bar chart for each of the what they call domains. So for each of the different types of weather. So if we evaluate that, then we get, let's make that bigger. We get different charts, boom, 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 for each type of weather. Whee! And so we haven't got much drizzle. That's probably not a very fair, accurate assumption of April. We should get more rain, and we get lots of sun. Yay! That's nice. So you can see, again, this is the same data. We haven't really changed much, but we get a very different visualization from Oz there as well. Boom, boom, boom. So I extrapolated pretty much most of that from the first sort of 10 minutes of the Oz video. So we go back to to 1. So if you go to the Oz website, which is not there, where did I put it? Clojure Oz. There's a really useful video to watch on the README. So if you go to this video, this is talking about the Vega-lite. So the relation between Oz and Vega-lite is basically Oz is generating, using Clojure data structures, it's going to generate the JavaScript, the JSON data structure that Vega-lite is going to use, and then that's going to be used to draw the visualizations. So this video is about Vega-lite and all the things you can do, but it does give you the code examples of the images that they're creating. So the first 10 minutes of that I've kind of recreated, and with a few tweaks and with my own data as well, because they don't actually give you the data that they're working with. So I've actually just done the first 10 minutes of that, and I'm going to delve into that a little bit more as well. And then there's also one specifically about Vega-lite, which has some more examples in there as well. And then the other approach I was taking was also going through the Vega-lite documentation. So if you go to the Vega-lite website, it's just vega.github.io. And to the Vega-lite section, there's a few different ones. There's Altar as well, which is another kind of visualization library, but I think I'm not sure if Oz uses both of these, but Vega-lite is the kind of the main one people talk about. It's the more abstract one. I think Vega is a little bit lower level and more specific, so you get tied up with more constructs, whereas Vega-lite is just basically a nice abstraction over Vega, which means you can just create these JSON maps and just express your visualization as a piece of data. And then with Oz, we're just really doing that with Clojure instead of JSON, instead of JavaScript. Although you can actually pull in JavaScript data as well. Yeah, so I've been going through, just experimenting with some of these marks as well, just to see if I can get them working. So each of these, we go into the arc example, and then it gives you all the different properties you can set and how to actually create it using this Vega-lite JSON data structure. And so you could I've just been typing these out into a Clojure data structure, which is more or less the same, and then seeing if I can get them to work in Oz. So let's have a quick look at that for the next 10-15 minutes, show you what I actually got working. Boop. Whee, there we go. So these are from the Vega-lite docs. And so there was a line plot, which, and I'm just using, so the mock data that I think I was using last week. So let's just see, let's go to that. So, boom, boom. So the mock data is just a simple function which just generates kind of this kind of information, just simple location cases, and so it's a fairly simple piece of information. Then I've just got a def to wrap that up, so we can just use UK confirm cases, or we can call mock dataset, which isn't a very good name, I don't think, to generate some mock data for England, Scotland, Wales, or Northern Ireland, or whichever countries you want to. So here we're just calling mock data set, and so obviously we could just call that for just one country as well if we wanted to, but we're going to try and compare those countries together. So if we do that, and again I haven't changed anything, I'm still running the Oz server. So if I evaluate that and go to number 1, and go back to my Oz. So we got the plot. So this is a plot we created, I think one of the plots we created last week. And so we're going to explore some of the other ones. And I didn't get everything to work, so I tried we created a single bar, which we've already seen. Oh no, we didn't see the bar, have we? So the simple bar is kind of like the next step up between the tick and a full bar chart, and that's just a simple kind of expression. So it's like how many there. So it's just like a single value in a horizontal bar chart. Actually, I'll prompt that back there for now. Boom, boom, boom. Let's put that back together. There we go. Boop. Boop. Oh, wrong button I was pressing. There we go. And then I tried to put a label on. Oops. I tried to put a label on this, but it didn't seem to work. So I tried to put this layer. So instead of using an encoding directly, you can use a layer. It says, but for some reason this wasn't working. It wasn't actually rendering anything, so I'm going to have to come back to that one. And then box plots. So it's very similar to the simple kind of bar chart, except this is adding a kind of a range in there as well. So this is showing kind of the range of this, and so the difference between this is, I've forgotten how to do this. Let me just check what I do. Yeah, so I created the encoding. This is the bar with access. Let me fold away. There we go. That folds away. There we go. I can see what I did now. What did I do? Oh, okay, right. Yeah. So this is a different type of visualization. So this isn't a bar. This is a type box plot, and we're using this extend value, which just shows how far the box plot extends beyond the actual kind of ranges of values. So these are different ranges of values. So you can see it's between like 10,000 to 34,000. So you can kind of see the range there between rather than just having a single total. You can kind of see the range of things that it's actually doing. It's there. Boom. Let's go back to block plot. There we go. So this is kind of useful when you want to compare kind of the range of something. So how like a trend of something, what's the kind of the minimum and maximum values going through there as well. So that's quite a nice way to express things. Oh, wrong one. And then I created a classic Gantt chart. So this is the Vega-lite data, and then I just convert this into pretty much the Oz version of that, so the Clojure version of that. And we've just got our data as normal. I just hard coded some data in there as well. It's just to emulate the disastrous waterfall approach to software development. And this is just a Markov bar, and then we've got some field types. So we've got X and Y, but we've got this extra X2 that basically defines where like things, when one thing ends, then another thing starts. So X is the kind of start, and X2 is like after that thing ends, then that's when the next one starts. So we get this kind of Gantt chart. If people are familiar, if people are that old, they remember what a Gantt chart is. I don't think we actually use these. Hopefully we don't use these anymore, because they're never right. But basically you do some analysis, do some design, do some development, and then your project fails. That seems to be classic waterfall. And these will be like months or years sometimes. But we don't do software development like that anymore, hopefully. Okay. Oops, wrong one. And then, oh yes, so then we did, so that was ranged bars, and then I tried to get pie chart. I was a bit annoyed I couldn't get pie chart to work for some reason. I'm going to give it another go because I wanted the donut, but it didn't seem to want to work. But no, sometimes some of these are not working, and it's just giving a blank screen, so that's not great. And so I think sometimes if you crash it, then if you just reload the page, that's one way to do it. You can also call the Oz start server again, and that should clear out the memory. I think Oz calling the start server again will actually create a new web page. So if you keep doing that all over and over again, you might have a few web pages to close. So just restarting the web page seems to be the most efficient way to do that. So if you get stuck, if you're evaluating something that did work, then it stops working, then just reloading the web page seems to be a quick way to get back to the start again. So I'm going to try and figure out why my pie chart's not working. I tried lots of different versions of that, but to no avail, unfortunately. And then one neat thing I saw here was like an image plot. So we can use images on our visualizations. So it's not just bars and colors and so on. And you can do all sorts of things with like bars. You can put rounded ends, and obviously we've seen colors as well. But you can also make a visualization more interesting by using images. So in this project, I've just added like 3 files. So if you have a look at PG, I've just opened my browser here. So in resources public and data. So basically resources public, then you can put in like the path to files. So put a data folder in there, and Firefox. So this path is data Firefox. That's not right. So if we evaluate that and we do image plots, and we get images on our bar charts, and so this is showing the kind of the assumed usage well, it's just basically plotting them on specific values. But yeah, you could just feed in like X and Y coordinates into there, and we've just got a mark of type image, and we're setting the width and height of the overall visualization, and then just the X and Y coordinates are where the images appear. And so you could do your own kind of Forrester's type of like trends, like how popular things are that you're doing. It's very easy to do that visualization here, and you can use logos in there as well. So you can kind of like say, well, which is the most popular language based on the data you get from Stack Overflow questions. Not that that's a very good indicator, but it's an indicator. That's something you could do, and instead of just putting bars on there, you could actually put in the logos for each of those languages. Oh, I might do that actually. That sounds good fun. Yeah, and so we're just using, we've got an encoding of a URL which just uses an image and just picks up the actual image file here. So this is the image here. So this is basically picking up the image key, and the image key is just pointing to a string with a relative address from our resources/public directory. We're doing. Oh, we've got a few minutes left. Did rule. Oh yeah, did stocks prices. Yeah, so we just did some fake prices for some stocks. Oh, that's Apple. I wonder what that was. Yes, Apple, Amazon, Google, IBM. These are not the right prices. I didn't actually look up to see what the real prices were, but you can create your own little stock ticker as well. You can create like how the stocks are going up and down, because they do go up and down. So you can write your own tools to be able to do your own trading and lose all your money that way as well if you wanted to. Okay, so we've done lots and lots of visualizations. Let's put them all together. So I've got a dashboard, and the dashboard is pretty easy to create. You just basically glue all your visualizations together. I've just defined a dashboard because it's quite verbose, because it's basically representing a HTML structure. So we've got the tags, so we have to wrap everything up into a single tag. So we use a diff. That's very common. So this is just a grouping of all the other tags together. So this is like our body of our HTML page, and then we've got headings, and then we've got, this is just a div to make a row, so we can put things along, and we make rows and columns just using the kind of fairly recent kind of Flex layouts that you get in most browsers. So this should work in pretty much most modern browsers. So not, i.e. Internet Explorer 7, that might not work, but you never know. So this is just creating, it's creating a maybe I haven't tested to see if that's a responsive design or not, but that kind of same kind of grid layout, rows and columns. And in this row, we've just got a paragraph, just some text, and then the most important thing is this Vega-lite thing here. So we've got all these Vega-lite entries, and this is just pulling in the views, because they've got like a view name associated with them. So we've got strip plot custom, weather, all the different weather histograms, and that's all you need to do to be able to create a dashboard. And so I've just used these rows and columns basically just to create a nice layout. But you could just have, or just it's the Vega-lite that does the actual presentation of the view. So let's evaluate all that. And then I've just got this view dashboard here, which again is just the same thing. So we're not doing anything different. We're just doing a view. And if we view that, then we get our final results. That's not the right. Where did my it's still back on there, isn't it? There we go. So we get our dashboard, which is too hard to see now. Let's move that onto there. That's what I was going to do. So we've got the visualizing the weather sections we've got. So we've got a strip plots and one with label, and we've got the different ways to represent the weather, and then we've got all the different views we've created from the Vega-lite examples as well. Simple. So it's actually really, really simple and easy once you've got the data in the right shape, and once you've learned some of the views you can create, then it's just a matter of putting them together, putting the metadata, as it were, around the actual data, the raw data you've got, and then just defining what type of visualization you're going to do, and then how you're going to map your data onto that visualization. Hopefully all made sense. It took me like a day or so to kind of work through all this, and I think just playing around with those things and converting some of the Vega-lite's data structures into Oz data structures, into Clojure data structures, did help kind of get me into the rhythm of what's actually involved. And there's a whole bunch of other things that you can add as well, which I'm going to try and extend over the next few weeks. So there's things like in the original dashboard, there's like a map, a geographical map. So you can add these as well with Vega. You can get not sure where they were there. Yeah, you can look for these GeoJSON formats, and you can use those to basically pull in a map, and then you can create that an interactive map, and you can update the colors and so on in the map, and you can put things onto the map. So yeah, looking for the right kind of GeoJSON thing, and then just wiring up with data, and create some really, really nice views there as well, just like that one. And then you can zoom in, and it shows like more details and so on. And you can also do shading, so you can have different regions. You can shade each region as to the number of things that are happening in that region, whatever they are, or like the weather patterns, the amount of rain you got in the region as well. So there's quite a lot of things you can add to that, and there's a whole range of marks you can add just by looking through the Vega-lite website. Oops. And then it's also got the other, so as well as marks, it's got all the encoding things you can do there as well. So we've only touched on some of those, and yeah, there's a lot more to kind of go and explore. But it already, for me, it already comes down to a fairly nice and simple thing, because we're just creating data, and so now it's just a matter of basically getting some good data sets assembled and figuring out how best to actually express them visually as well. Okay, I'm going to leave it there. Apologies for the sound issues. I'll do better next time. And hopefully you understood everything. If you've got any more questions, then please let me know. Feel free to reach out to me via the Practicalli website. Oh yeah, I'm going to do. I'll do a blog that covers this stuff as well. But feel free to reach out to me via the Slack channel. Clojure is black. You can also send me direct messages as well if you don't want to ask any questions in the open. And yeah, thank you very much, and have fun exploring data science with Clojure. Thank you very much. Goodbye.